Hi everyone, Miss Mason here from Capture the Star. Today we're looking at solving systems of equations by graphing. This is from our Systems of Equations unit, MPM 2D, Grade 10 Academic Math. Now just before we begin, I would like to share a special note on slope, what it means, and how to use it. Now slope is a coefficient of x in your linear equation, and it is most often referred to as the m value. It helps us find other coordinates on a line, and we would move both vertically and horizontally in order to do so. Now we're always starting from our b value, that's our y-intercept. So we're starting along the y-axis, and we're using one of the four basic types of slopes that you can encounter: a positive slope, a negative slope, a slope is a whole number, or a slope is a fraction. Now these four types of slope will help us locate a different coordinate on the same line. Let's break that down a little further. So a positive slope means from your b value, you're going to move up and to the right to locate that new coordinate, or down and to the left. For a negative slope, it's the opposite. You'll move up and to the left, or down and to the right to find a new coordinate on your line. Now if your slope is a whole number, the m value is a whole number, you will still be making two movements. However, your whole number will indicate how many units you move up or down, and you will always move one unit right or left. Now, if the slope is a fraction, do not panic. That numerator, it tells us how many units you are moving up or down, and from there, the denominator tells you how many units you move left or right. Let's practice. Here we have y equals 2x plus 1, our y-intercept plus 1, slope plus 2. Now in order to plot this linear equation, we start with our b value, which is plus 1. So you go and find positive 1 along your vertical axis, plot your first coordinate there. From that point, use your slope, which is positive 2, to move either 2 units up and 1 unit to the right, and continue on that pattern, or 2 units down and 1 unit to the left, and continue on that pattern. Now once you've found 4 or 5 coordinates along the same line, connect the dots, and you have successfully graphed your linear function. Now, do you remember how to convert from standard form into y equals mx plus b form? For example, 9x plus 3y equals 15. This can be done in 2 easy steps. Step 1, shift the 9x over to the right-hand side of the equal sign. Step 2, divide out by your coefficient of y. There, we will have y equals negative 3x plus 5. So keep that close in mind. This is the exact same strategy you will use to find a point of intersection by graphing a system of equations. Here are the 4 steps to finding a point of intersection by graphing. Step number 1, rearrange the equation into y equals mx plus b form, if necessary, and color code them. Step number 2, for the first equation, plot the y-intercept, that's the value without a variable, and use your slope, the m value, to find more points on your line. Connect the dots with a straight line. Step number 3, repeat step number 2 for the second equation. Step number 4, simply identify the point of intersection, and you'll be able to see this visually. Example number 1, that's y equals x plus 1 and y equals 2x plus 3. Step number 1, rearrange your 2 equations into the y equals mx plus b form and color code them. Here, both equations are already in the y equals mx plus b form, so we're going to go ahead and just color code them. Step number 2, we're graphing our first equation. We're starting off by plotting our y-intercept at positive 1 and using our slope to find other points along the same line. Complete your graph with a straight line here. Step number 3, we're following the same steps as in step number 2, but this time for our second equation. So we're starting at our y-intercept of positive 3, and we're using our slope in order to find other points on the same line. Step number 4, we visually see on our graph where the 2 points meet. That's our point of intersection. Our point of intersection is at coordinates -1, -1. So let's kick it up a notch. This is example number 2, 5x minus y equals 6 and 2x plus y equals 8. Step number 1, rearrange your two equations into the y equals mx plus b form and color code them. So our first equation is 5x minus y equals 6. We're going to move that 5x over to the right-hand side of the equal sign and then divide out by the coefficient of y, which is -1. We're left with y equals 5x minus 6. Our second equation is 2x plus y equals 8. Again, we're going to shift that 2x over to the right-hand side of the equal sign, and that's it. We're left with y equals -2x plus 8. So the two equations that we'll be using are y equals 5x minus 6 and y equals -2x plus 8. Step number 2, graph your first equation, y equals 5x minus 6. Now we start off by plotting our y-intercept, which is -6, and we're going to use our slope, which is +5, to find other points on the same line. Step number 3, graph your second equation, y equals -2x plus 8. So again, we start off by plotting our y-intercept at +8, and we use our slope of -2 to find other points on the line. Step number 4, we can visually see what our point of intersection is on our graph. That's the coordinates of 2 and 4. There are 3 core skills you need to succeed. We're going to start it off with converting the standard form to y equals mx plus b form. That's essential. From there, you're able to plot your y-intercept and use the slope to find other coordinates on the same line. You're going to repeat this step twice because you're using a system of equations. There, on your graph, you'll be able to see where the two lines meet, and that's their point of intersection. And just like that, you've become a master of solving systems of equations by graphing. Thanks for watching.